Hereby, I open this academic ceremony in which Ting Wang will defend the academic thesis called Dissecting Visual Attention on the origin of attentional bias, alerting, and orienting effects. May I invite you to present a summary of your study and the conclusions of your thesis? Yes. Go ahead.
Highly esteemed proctor, members of this opposition, and supervisors, and dear colleagues, friends, and family, thank you all for joining me today in person or virtually for the defense of my thesis entitled Dissecting Visual Attention on the Origin of Attentional Bias, Alerting and Orienting Effects. Talking about visual attention, it exists everywhere in our daily life. Consider you are browsing through a bookstore. Your visual attention will allow you to focus on book titles or specific genres to find something to read. However, this situation might be different for spatial neglect patients. Neglect patients may ignore one side of their environment or body, so they might think as this. Because for spatial neglect patients, they have attentional bias towards one side and ignore the other side. Spatial neglect is most often due to the damage to the posterior parietal lobe, and the damage to the right hemisphere is more often and severe than the left hemisphere. To understand the visual attention, learning mechanism from patients is limited because the lesion cannot be controlled. Similar to lesion study, neuroscience techniques like transcranial magnetic stimulation offers a way to understand the mechanism of attention. TMS is a non-invasive brain stimulation that can generate magnetic pulses through coils placed on the scalp that can affect the underlying brain tissue. It can be used to excite or inhibit the cortex function, and it can produce what is known as virtual lesion in the brain. This approach allows researchers to simulate brain injury and observe changes in behavioral performance. However, can we use TMS on parietal cortex to make virtual lesion to mimic spatial neglect? In the past decades, researchers used TMS to understand attention and found a line bisection task. For the line bisection task, participants need to find the midpoint of this line, and healthy participants will mark the midpoint here. But for neglect patients on the right hemisphere damage, they will mark the midpoint here because they have attentional bias to the right side. And it's similar to the left hemisphere damage neglect patients. So we can see that for neglect patients, they will shift their attention to the ipsilateral hemifield. So if TMS can mimic spatial neglect, then no matter whether the TMS positioning on the right or left parietal cortex, they will show like the middle point shifted to the ipsilateral field, and importantly, the right shift effect is larger than the left shift effect. In part 1, chapter 2, we conducted a meta-analysis study to check the left and right hemisphere TMS effects across previous decades studies on line bisection tasks. It turned out that TMS can cause an attentional shift towards ipsilateral visual field, and this shift effect is significant in the right hemisphere but not the left hemisphere. Thus, it verified that TMS on parietal cortex can mimic spatial neglect syndrome. But why spatial neglect is more often and severe after right hemisphere damage this question cannot be answered in this study. Talking about why neglect is more severe after right hemisphere, there are two mechanisms proposed by Hyman and Kingsburn. That's hemispatial theory and interhemispheric competition theory. Hyman proposed that left hemisphere control the right side, and the right hemisphere control both sides. So once left hemisphere is damaged, the right hemisphere can compensate for its function. However, if the right hemisphere is damaged, the left hemisphere cannot compensate. Kingsburn proposed that both left and right hemisphere control the contralateral visual field, but they exist inhibition to each other. So once left hemisphere is damaged, it will lose the control to the contralateral visual field, and at the same time, it will lose the inhibition to the other hemisphere and cause the ipsilateral enhancement. And it will be same for the right hemisphere damage. However, this whole system is asymmetry, so it will show kind of right hemisphere dominance. A dispute between these two theories existed for decades. So can we find evidence to support these theories? A visual detection task can help us to achieve this goal. The visual detection task requires participants to determine whether the target shows on the left or right or both bilateral or neither on the screen. The task can not only separate left and right visual field, but also can separate the prediction from Hyman and Kingsburn's theory. So for Hyman, it predicts that contralateral visual exists an impairment effect. And for Kingsburn, there is not only contralateral visual field impairment, but also ipsilateral visual field enhancement because of lack of the inhibition for the other brain. So the key point is whether there is an ipsilateral visual field enhancement effect. In 2001, Higtag published a high-impact paper on Nature Neuroscience and provided the evidence for the ipsilateral visual field enhancement effect. However, whether this evidence is consistent across studies has not been checked. So in part 1, chapter 3, we conducted a meta-analysis study about left and right hemisphere TMS effect on visual detection task to aggregate these contralateral and ipsilateral visual field changing effects. It turned out that there is a significant contralateral impairment effect, but does not support the ipsilateral enhancement effect, which challenged Kingsburn's theory but supports Hyman's theory. To sum the part 1 of my thesis, we focus on attentional bias by using meta-analysis for TMS on on healthy individual parietal cortex based on line bisection task and visual detection task. We found that it's possible to use TMS on healthy individuals to mimic neglect syndrome, and there is no ipsilateral enhancement, but only contralateral impairment effect when caused the attentional bias. Although all these studies based on healthy participants, the conclusion in part 1 are inspiring on clinical brain damage rehabilitation. Attention is not fixed as in case of the attentional bias, but it's highly flexible and can be controlled. Attention can be controlled by different kinds of cues or stimuli, such as alerting cue and orienting cue. In a spatial cueing task, we could manipulate both alerting and orienting cues to generate alerting and orienting effects of attention. Typically, the alerting cue provides the information of when the target will show, and the orienting cue provides the information where the target will show. Normally, we compare neutral versus no cue as alerting effect, and the spatial versus neutral as orienting effect. However, both alerting and orienting effect only rely on the response time, and the response time can provide limited information. Why do we say this? Because from stimulus input to response output, that includes stimulus encoding, decision making, response execution, and all this response time counts. So when we talk about alerting and orienting effect, how can we know which part we get benefit from? The drift diffusion model can help us to decompose the response time into decision time and non-decision time by estimating several parameters. For example, the decision time defined by drift rate, which reflects the speed of uptake of information, and the separation threshold, which means the amount of information considered for a decision. And the non-decision time consists various components before and after decision processes. So in part 3, chapter 5 and 6, we conducted studies including DDM on spatial queuing tasks. And we found that for the alerting effect, we only get benefit from decision and non-decision processes. But for the orienting effect, there's only impact the non-decision processes. However, since the non-decision time includes various components, but it only represents by one single parameter T0, can we further dissect the alerting and orienting effects? At this point, utilizing a high temporal resolution tool can add on with complementary information. Electrophotometer, or EEG in short, is this high time resolution tool. It could get info signals in milliseconds level. So if we can get this alerting and orienting effects with this kind of information, effectively dissect alerting and orienting will be promising. So in chapter 7, we revealed combined with EEG and revealed that the EEG signal provides information for alerting effects before target present. So it will be the early stage of the non-decision time. But for the orienting effect, it shows the middle-late stage to the effect. So taken together, part 3, combined with DDM and the EEG signals, we successfully disentangle the alerting effect and orienting effect. And the alerting effect comes from the cognitive resource allocation and decision-making stage, and the response orienting effect comes from response preparation and execution stage. To sum up, in my thesis, I used the meta-analysis, DDM, and EEG to dissect visual attention. Although all these studies are based on healthy participants, they still could inspire researchers for neglect rehabilitation in the future. Thank you very much for your attention, and I hereby give the word back to the director.
Okay, dear candidate, thank you for your presentation. The opposition will be opened by Professor Peter de Weert, who is Professor of Neurosciences of Perceptual Learning and Attention here at Maastricht University. Professor de Weert, please go ahead.
Thank you, Prorector. First of all, congratulations for your thesis. It's an amazing amount of work, so I want to explicitly congratulate you for this. It's lots of work with different methods, and I understand not always did you collect your data in the most easy of circumstances? So it's really nice to see this work coming to completion today. I would like to ask a simple question to start. I see that sometimes in your studies you mix Chinese and Western, I guess mostly Maastricht-based participants. And maybe I didn't read carefully, but did you do anything with this? Did you analyze this data separately?
Highly esteemed opponent, thanks for your compliment and question. So you're asking me that I have both Chinese and European participants, whether they have different, and whether I analyze this kind of data. And I indeed analysis the difference between Chinese people and the European people, and it shows there's no significant difference. At the beginning, we thought there might be some processes may be different because it cannot be revealed, only rely on the RT and accuracy. However, if we add a DDM, we can deeply like to divide it into subcomponents, and we guess maybe there might show some cultural difference, but we didn't find this in both exogenous and endogenous queuing tasks.
Yes, that's interesting, because I would have thought there might be some difference based on the differences in language system, and in your language characters can go from top to bottom and it doesn't matter, whereas we are of course used to read from left to right, so interesting. Now I would like to ask you a slightly more difficult question. I would like to ask you something about the literature review, the meta-analysis that you did. I very much like the idea of meta-analysis because when you put everything together, you usually get a better view of what the true finding is. You get closer to the truth. The thing I wonder is, you were so strict in selecting studies, and you went from 814 or something down to, I think, about 11 studies. And then you made your conclusion about the difference between the two attention theories. Do you think that the way you selected, or the stringency of your selection, is a problem for the conclusion that you come to at the end of your meta-review?
For this question, yes, I also considered for the criteria. At the beginning, we want to check this virtualization mimic thing. So this we pick the inhibitory TMS effect. So it includes RTMS and CTBS. There has already a lot of protocols, but at the same time, we didn't include TACS and rhythmic TMS because we think it will be better to set between, not to go too far, but still get this consistent inhibitory effect. And the other thing is that although we have only, for example, in the chapter 3, only 10 studies, but still they include around 200 participants. And also this effect has already been checked by the Bayesian meta-analysis. For the Bayesian meta-analysis, it can give the benefit that ignore the sample size. So we didn't worry about this sample size.
Okay, thank you. Actually, while I was listening to your nice presentation, I asked myself also the question, is it necessarily true that one or the other theory has to be correct, right? So in a way, now the research is set up to sort of reject one theory and say the other theory is correct. But could it not be that both theories are correct?
Yeah, I agree. So in the chapter 3, we just say that we didn't support the key point of Kingsbury theory, but can provide the support for Hyman's theory. But it doesn't mean that Kingsbury is totally wrong, because in the clinical part, the ipsilateral enhancement effect is a kind of base for the neglect rehabilitation, and on the clinical part, they still find that this ipsilateral enhancement can support to help the neglect patients to be healthy using the TMS. So it's like maybe from the clinical part, we start from healthy participant to the clinical part. It can inspire for the future study, but it doesn't mean that we can directly use the conclusion from healthy participant on clinical part.
Okay. Is it necessarily the case that in the not the Kingsbury theory, but the other one, you don't ever expect any ipsilateral enhancement? Is it so? The ipsilateral enhancement is something that you associate with the Kingsbury theory, right?
Yes.
If you would suppose that both theories are true, how would you test this? I may be wrong, because I'm now just thinking this out while I'm sitting here, so likely I'm wrong.
No.
But
this is a good question. I know I get what you mean. It's like if so currently the meta-analysis provide the evidence only for Hyman's theory, not for Kingsbury. But if the truth is that both theories are correct, or even there is a hybrid model, like we use this visual detection task is not possible. So we need to maybe find another one. But it's like we need to get the mini difference between Kingsbury and Hyman. But currently, the only thing we can find is this ipsilateral enhancement. Okay. So that's why we focus on visual detection task.
Okay. We have to shift to the next opponent. Thank you. The opposition will be continued by Professor Vincenzo Romai, who is Professor of Cognitive Neuroscience, and he is affiliated with the Center of Studies and Research in Cognitive Neuroscience, Department of Psychology, Renzo Canestrari at the University of Bologna in Italy. And thank you for coming all the way to Maastricht. Professor Romai, the floor is yours.
Thank you. So I thank the candidate for the very interesting work that you have presented, because you have really worked on a very important topic, and as you have demonstrated, things still are way far from being resolved, and you have just made an important contribution on this. So the meta-analysis, that is the part that I would like to start with, are something that intrigued a lot, because indeed there's a lot of interest in these models, and I think things are developed lately in different ways. So one thing that I would ask is, for example, regarding the measure that have been used. So you have said the TMS has been used, and you have taken into consideration mostly inhibitory protocols, right? So there are several protocols that have been used. So one thing is about the model behind what the TMS is doing, for example. And and this would be one thing that is interesting. So would be that the kind of TMS protocol were those that could be best suited to test this hypothesis. But as you've said, inhibitory protocols were probably according to the virtual lesion approach, so were exactly what you were looking at. So I'm still wondering whether, for example, for the intrahemispheric inhibitory account, you might look into other mechanisms that might highlight that effect. For example, looking into oscillatory activity as a way of looking into it. And the second point is about the measure of the task. So what is the performance of the subject? So generally these studies that you have looked at are looking mostly at accuracy or hit rate, right? Response. And I wonder whether, as you have greatly done using computational models like DDM, whether we have lost something on the way, because, for example, a confound between what is a perceptual component and a bias in the decision process, which from this study in the meta-analysis you could not tell. So I wonder whether this might have created an issue in the confound, let's say, in the way in which you have looked at the data. So simply because the past literature have not looked properly into this. So that would be my first point.
Highly esteemed opponent, thank you for your compliment and question. So you asking me first question is about the meta-analysis measurement, like for the I choose the in-between protocol, like only include the inhibitory TMS, but not with the oscillation or the like rhythm entrainment TMS. So because we still think like the inhibitory TMS effect for the RTMS and the CTBS, it's just for us to to find the behavioral changes, but not with the oscillation shift. So it's kind of different mechanism with the entrainment part, and if we include this, there will also it's unfair to not include the TACS. Then there will be very big of this data set, and that's the most reason that we didn't decide to include it. Yeah, and the second question, so you're asking for the DDM part. We focus on the for example, the perception and the non-decision part. This may be reflected by the oscillation, and it kind of can be linked to the meta-analysis part because they show the right and left hemisphere dominance. But in chapter 6, we try to use the DDM, and also in the chapter 7, we try to use the EEG, which want to find maybe right hemisphere and the left hemisphere asymmetry. But it shows that the DDM, or we say that non-decision time and the decision time parameters didn't show any difference, but also the response time and accuracy on the right and the left hemisphere comparison.
Okay.
Yeah.
Okay, thank you. So then going exactly more into the your experiments, one thing that I was wondering is, so you've considered using the DDM model, and there are other computational models that are interesting, and probably one of the most classical now is using signal detection theory. So the idea of looking again at, you will not have information about clearly reaction time, which I understand is very important in your case, but you still would have the ability to see as for alerting versus orienting, the ability to dissociate dimension of sensitivity and criterion. And I was wondering whether there's any chance that you could integrate. I mean, whether you have looked into this and you could see how these elements like sensitivity and criterion relate to measure of the DDM. So to further validate what you're looking into. So have you tried or have you thought of this possibility?
Yeah, this is a good point. In my chapter, I also mentioned this signal noise because for the signal noise of this part, we kind of predict. We think it correspond to the DDM parameters V and T0, but we didn't do this yet, but because this paper is not published yet, and we have a plan for the future analyzing. Yeah.
Okay. And regarding the EEG, I have one very intriguing point to propose to you, which is something regarding the measures that you have used, because I've seen that you have used several parameters from ERP measure or oscillatory measures, and one that is missing in your analysis about the individual alpha frequency. And as we have seen that it might be related to, let's say, the gain in perception, I was wondering whether it would be ideal to use individual alpha frequency as one pattern that could anticipate your performance, especially in the orienting component, which I've seen at the moment doesn't seem to be related to any of your measures, not even the alpha power, which would not be expected in the end, according to the recent literature. So I was wondering whether it could be integrated, so you could look into individual alpha frequency as another parameter that could account in the DDM specific component. I can imagine drift rate.
Yes. For this part, for the EEG analyzing, we didn't separate the left and the right hemisphere or regions, and also because the alpha suppression effect is only showed that to the attended field and unattended hemifield. So this might be reflected in the left and the right hemisphere or regions effect, but we didn't analyze this yet because, so for current thesis, we only want to find the alerting and orienting effect and to decompose it. So we just want to get the very simple version, and for the more complicated about the hemifield or the alpha attended and attended part, we will for future analysis. Yeah.
Okay, thank you very much.
Thank you.
We have to shift to the next opponent. The next opponent is Dr. Paul Taylor. He is with us online, and he is working at the Faculty of Psychology and Education at Ludwig Maximilian University in Munich. Dr. Taylor, the floor is yours.
Thank you, Pro-Rector, and I'm very grateful to have the opportunity to be here. I'm honored to be on this panel and in the company of such esteemed colleagues. Thank you for your thesis, dear candidate. It was very impressive, both in quality and in quantity of work. And I very much enjoyed your very clear presentation. I would have a few questions, of course. One smaller question, some general questions. So one smaller question, I noted in your meta-analysis, you found a significant publication bias. Can you elaborate on what you think that means?
Esteemed opponent, thanks for your question. So you asking me for the meta-analysis part about what does it mean for the publication bias. So for
Yes.
publication bias, it's like most of studies will to check kind of effect and found it's significant or not insignificant. But for papers, they have a tendency more likely to accept a significant effect. So this kind of paper is more likely to be published. And for the insignificant part, will be kind of in the box. So it will be show kind of publication bias to significant effect, but will not so many insignificant result was published. Yeah.
Thank you. What do you think could be done in the future to prevent a publication bias on this topic?
Sorry, could you please repeat the question?
What can we do to prevent the publication bias in the future? How can we stop there being a publication bias? What steps can be made by us or by other people?
Okay, so there will be like two aspects for the for the researchers. So first, like if we like to read or we say like read literatures, we need to like to check or we say check the effects, and also when we do researches, we need to report more details about your results. For example, the very original statistical data, and also you need to report effect size. This is important for future meta-analysis. And if you do meta-analysis, then you need to like to do kind of trim and fill to decrease this publication bias. And for the other perspective, it's like for the publisher, it's like they will like how do you say, respect the truth and show everyone the real effect. Yeah.
Thank you. That's a very interesting answer. I do take your point. Interesting what you mentioned about the trim and fill aspect. Thank you. I had another little question. I noticed again in the meta-analysis that you found there was no significant difference between the left and the right hemisphere. So they weren't different, the left and right hemisphere stimulation. What do you think that means?
For the you mean in the chapter 3, we didn't find the left compared to the right hemisphere effect, but in chapter 2 we find this significant effect. So because these are two different tasks. In the chapter 2, this is a line bisection task, and in chapter 3, it's a visual detection task. In the line bisection task, it's kind of because maybe the line bisection, this process, because it includes the magnitude processing, and this is kind of right hemisphere dominance. This might be the reason why in the chapter 2 we found this dominance, but didn't find the difference between left and right hemisphere in chapter 3.
That's a good answer. I like your idea. So this is about the right hemisphere being important for magnitude and that not being picked up by the visual detection task. Okay, that's fine. Yes, thank you. I now have a more general question. So you've mentioned in your thesis about relating your work to clinical treatment, about what it means about using parietal TMS to try to rehabilitate people after stroke. As you know, TMS is also used for other disorders, not just stroke. Do you think your results can also tell us something about how we should use TMS to treat other disorders?
For other for other diseases like depression, anxiety, all these kind of psychiatry parts. For example, on my chapter 4, it helps us like to more specifically focus on localization of the TMS. But for the meta-analysis part, it's kind of show the right and the left hemisphere dominance, and we also can say that this mimic the syndrome, and it might show the effective of the TMS method, and it can also be helpful for the clinical part. And then go back to the chapter 4. We found maybe an alternative way to localize a more precise TMS target. So combine the TMS can mimic syndrome, and then to more specific localize. So this could kind of inspire for other psychiatry or clinical diseases.
That's very interesting. So you mentioned TMS and depression. How do you think people should localize the target for TMS with depression?
Because TMS has a very useful localization method, like using the network, function network or structure, and there is a very popular method. It's like using the functional network to find, for example, the DLPFC, using the SGACC to get the negative correlation, and using this way to localize, and this is useful methods. But in my chapter 4, it's like if you don't have a specific task, or you didn't find this individual hotspot of your target, then you can transfer to a group way. Group map can help you to get this localization.
Great. I like how you mentioned the relationship between that resting state use in depression for the connectivity between the ACC and prefrontal cortex. So do you think people should not do that? And do you think they should instead use a task for activating prefrontal cortex for depression?
We have a short answer. Huh? We have to move to the next opponent.
Okay. So I think for this question, people can use or we say the hotspot. It's perfect, but this is like a group part is an alternative way when it's not available. Yeah.
Thank you.
Next opponent, and that will be Dr. Frans Mulders. Dr. Mulders is working in the Cognitive Neuroscience department here at Maastricht University. Please go ahead.
Okay, thank you. Congratulations, dear candidate, with the interesting thesis. I think doing the DDM analysis, distribution analysis, is an excellent idea to find out the nature of attention effects. So my questions are about chapter 5 and 6, in which you do that, and I was especially impressed by your choice of the stimuli. It is these moving dots among noise, which make it pretty likely that the information is gradually dripping in, gradually accumulating. So these were pretty hard stimuli. You didn't use dot stimuli that are also often used in attention research. But then when reading on, I also saw that you used the staircase procedure to get to 75% correct only. And on top of that, you present a stimuli for only 100 milliseconds. Now, 75% correct is, I think, what you get in a two-choice task. Chance performance would be 50%. So 75% correct would mean that participants couldn't discriminate half of the time. So half of the time they were wrong. So I wonder if you've been too tough on your participants, where you made the task too difficult for them. So you maybe you simply boldly cut off the gradual accumulation of evidence, and maybe that's the reason why you didn't find anything on this drift diffusion process itself. All the effects that you find are on this non-decision time. So why did you do the 75% correct? And would you expect maybe different results if you had done it differently?
Esteemed opponent, thank you for your question. So you are asking me like in chapter 5 and 6 why I use the moving dot stimuli and the staircase why I set at 75%. So first the moving dot stimuli, because normal we use the spatial cueing task using the gratings, but the gratings syndrome is fixed, and when you using the DDM analysis, you need a time to get or you say to do this evidence accumulation. Yeah. So for this part, you need a kind of change for this stimuli. So the moving dots, that's why we pick the moving dots rather than the gratings. And for the staircase, because for the DDM analysis, we need the distribution of the correct answer and the incorrect answer. So we need enough trials for the incorrect answer. And if the incorrect answer is not correct, this estimate will be like show something problem. Yeah, that's why we picked this 75%. Yeah. And you also mentioned that it's kind of between chance level and whether this will cause that our effect is not significant. Mm-hmm. And for this part, I think like because our current design didn't include like invalid trial or like more higher accuracy, so we can't say that directly that this is that reason, and maybe this can be detected in the future research. Yeah.
Yeah, I see. Yeah. Well, about the errors, I'm just wondering. Mm-hmm. I can understand that you need sufficient errors. Yeah. But you would like the errors, I think, to occur because your boundary is pretty tight. So the participant felt stressed to be fast. But what you did is actually cut off the evidence accumulation at 100 milliseconds, because then the stimulus was gone. So there was no option to accumulate anymore. That's just a hunch feeling that I have. So because 100 milliseconds is so short.
Yes. So that's for the exogenous cue for 100 milliseconds. But for the endogenous cue is 1,500 milliseconds.
Yeah, but not the target.
Yeah, the target. Yeah.
The target is still 100 milliseconds.
Yes. But you have an impression about the moving dots. And between this 100 milliseconds, so you think like 100 milliseconds is too short for participant to do this evidence accumulation?
Yeah, I guess. Yeah, you have a lot of errors, so that confirms my idea.
Okay, yes. But for the average accuracy, it's still around 75%. Yeah. And I think for most participants, they can distinguish the moving dots go up or down, and it's kind of to keep the accuracy, but also we need the number of trials, and it's kind of a balance between this. As your question that the time is too tight, that's because we don't want to like give this time window too long, then it might be, for example, for the exogenous cue, there will be inhibition, reaction inhibition, yes.
Yeah, inhibition of return. I see, yeah. Okay, thank you. I had another question about the effects that you find of orienting especially are mainly on this T0, the non-decision time.
Yes.
And it's very clear that you obtain those results, so I agree with that. But in fact, non-decision time only tells you that the actual evidence accumulation and the thresholding, etc., is not affected. So it mainly tells you what is not affected. And so you would need other methods to find out what is affected. And you used EEG for that. And there, you as you just presented to us, you find evidence for a late effect of orienting.
Yeah.
Now, I wonder, if you look at the difference between the neutral cue and the directional cue, one simple idea is that you can simply orient your attention based on the directional cue, but not based on the neutral cue. So with the neutral cue, you would have to orient your attention after the target is happening. So you orient your spotlight after the target. So it could be simply this this orienting, which is again an early effect. Would that still be possible, you think?
So you're asking like...
please give a short answer for time's sake.
Yeah. Okay. So, it's like because of our parameters and also the DDM showed like for the attention allocation, this resources allocation is only show the queuing task, or we say the alerting effect, but we didn't find the orienting effect on the EEG part. So this early part we didn't find it. We think it may be more related to the later stage rather than like a very beginning.
Because the absence of an early effect. You conclude that because of the absence of an early effect. I see. Yeah. Okay, thank you.
Okay, we now go to the next opponent, and that is Professor Sonja Kotz. She is a professor in neuropsychology and translational cognitive neuroscience at this university. So, Professor Kotz, please go ahead.
Thank you, Prorector. Dear candidate, first of all, let me congratulate you to this really, really nice thesis, extremely well written and clear. I enjoyed reading it, and I would also like to extend my congratulations to your supervisory team. I also appreciated your presentation quite a bit, and I would like to follow up on a couple of questions that have been touched upon. And one is that I really liked your answer to Dr. Taylor's question about meta-analysis, and I kept thinking that meta-analysis can only be as good and informative as we report our data, which you kind of nicely pointed out to us. But somehow in the field, and that's across many, many domains, these meta-analysis become the gold standard and may even inform how we run our experiments. That's rather tricky given your very interesting critical position on that. So I'd like to hear from you again what you think meta-analysis can really serve in terms of our science.
The opponent, thanks for your compliment and question. For the meta-analysis, it's a kind of aggregate all of previous studies. To some extent, it kind of fix the difference between each studies, but get the common parts. And then we we can generate a conclusion through all these results. It's kind of an overall effect for the current studies work on the same topic. And this conclusion is more effective than a systematic review. And it's kind of how to say, maybe a guidance for the future study. One part is that maybe as my chapter 3 or the theoretical contribution, or the other like chapter 2, for example, get a conclusion that something is useful or not useful, and this is meaningful for experimental studies, and maybe you can get a very easy conclusion only using this one single literature, and then you can design a better or more perfect experiment. And then for the theoretical part, it's like kind of challenging for previous studies, but still, if you do an experiment, you still get a different maybe conclusion to some theories. But this meta-analysis give a more, always say, a stronger evidence, and it can, for example, help you to more brave to publish your some challenging results. Yes.
All right. Very, very nice reflection on this. So much more differentiated how we can use them. I appreciate that. I'd like to quickly focus on chapter 4, and that also relates to your proposition 5. And in the interest of time, I will quickly read it out. In cases where localization failed in an individual subject, using a group task localizer which incorporates data from the remaining subjects was often effective. So what you're saying here is that depending on the type of MRI measure that we use, we end up probably be better served by using ROI-based analysis on a group average. Now, that kind of counters what a lot of work in cognitive neuroscience is currently pursuing, and that is that we should go more individualized, whether that is in empirical research or whether it affects rehabilitation. So what is your position on that? And under what premise do you think group analysis are more important, or group types of ROIs are more important than individualized ROIs?
For the individual, task individual, for a long time it's been seen as the gold standard. But for example, a task, when the task is very time consuming, or we cannot find a proper task to get this collector or accurate this individual data, then maybe there is some existent data set, for example, HCP. We can use their tasks and then get this group activation to help help us to maybe to generate cortex-based coordinates. And this is an alternative way. For the group, when we say it's time-consuming because it's we need to generate the group map and then project to the individual map. But still, when we collect data, we need to collect at least 20 participants, and that's not so complicated to generate this group map and back to the individual map. So it's like, for example, number 6 participant cannot find the individual task activation, then you can generate the previous 5 and then project to it. It's also an alternative way. Yeah.
Mm-hmm. But I mean, if I look at the different uses so you use task-based ROIs, you use dressing state ROIs, and you used DWI ROIs, for example, in your chapter 4. And you noticed, for example, that individual resting state ROIs were far less informative than task-based ROIs. So what's the benefit of the 3 different measures in that sense?
So for the individual, for example, the individual functional connectivity, it's more easier to get and less time consuming. And as we, sorry.
You can still answer the question briefly.
Okay. So, for example, the SG, ACC, and the DLPFC is a nice way to make a hotspot, and the DWI is also very useful because it's a structural connectivity and you can get the network localization. So there are benefits for the individual methods. Yeah.
Thank you very much. And I give back the word to the pro-rector.
Professor Kotz. Ting Wang, the time appointed for defending your thesis has passed. The degree committee will now withdraw to discuss the quality of your thesis and your defense. I request that you and your company await the results of our deliberations and our return in this room.
The PhD defense has now ended. The degree committee will debate the candidate's performance behind closed doors. This process usually takes about 10 minutes.
Long road to the south side. 10 miles in my rearview mirror, I know what it felt like. My goals only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and die. On the line, I know you know that I can't read your mind. Years can't fly by now, don't waste all your time. Cause I'll go the extra mile. Long road to the south side, 10 miles in my rearview mirror, I know what it felt like. My goals only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and die. On the dash, got my laces tied. Long road, I don't waste no time. Break rules because fate decides. With the team and we chase the light. I make a move, fall down, shake it off. I hate to lose, bad branch, break it off. No room for negativity, praise and love. Prepare for deep part cause we're taking off. Take the mileage, traveling so far from home. Gathering knowledge, other connections. I put the time in to get everything I ever hoped for. It's a challenge and we all in. It's a better future that we go for. And even though these nights seem long, I know that I am never on my own. Know you've won the battle once you've grown. South side, 10 miles in my rearview mirror, I know what it felt like. My goals only getting clearer, east side to the west side. No place like home. If it's questions that you've got, go the extra mile and that. Long road to the south side, 10 miles in my rearview mirror. I know what it felt like. My goals only getting clearer. East side to the west side. No place like home. If it's questions that you've got, go the extra mile and that. Years can't fly by now, don't waste all your time. 'Cause I'll go the extra mile.
Okay, let's open this once again. Ting Wang, the degree committee here present and online has assessed the quality of your thesis and your defense. In view of its positive verdict and taking into account your previous qualifications, the degree committee has decided to grant you the degree of doctor. And Professor Sack is authorized to confer upon you this academic distinction in accordance with Dutch university custom, and I invite your supervisor now to take the floor.
All right, please.
Not in Dutch. Do you promise to work in accordance with the principles of scientific integrity at all times, to be careful and honest, transparent, independent, and responsible?
Yes, I promise.
By the authority vested in us by law and in conformity with the decision of the committee here present, I hereby confer upon you, Ting Wang, the degree of doctor and grant you all rights attached by custom and law. As evidence of this, I now present you with a degree certificate signed by the rector, the secretary, and the other members of the committee, and affixed with the official seal of the university. So, Ting or Dr. Wang, on behalf of the Brain Stimulation and Cognition Group, I would like to congratulate you, of course, for your doctorate, and I want to express that I'm personally extremely happy and extremely proud of your achievement. And before I give the word to Felix, who will say a few words about you, I would also like to say a few words, and I would like to start with reading out the first sentence of your acknowledgement, because I think they say it all. Of course, I need my glasses for this. In your acknowledgements, you write, and I quote you now, "When I start to write this acknowledgement, I realize that my time in Maastricht is drawing to a close. In the last 4 years, I had a lot of fun and hard time. I love people here, enjoy cooking by myself. At the same time, I hate the weather and transportation system. But this is Maastricht, this is the Netherlands." I think this is a perfect summary of not only your journey here, but also of the Netherlands. And it made me also remember the long journey you made actually here in Maastricht. I think it was 2019, we're not entirely sure, but yeah. You came to Maastricht and we met you at Banditos, we had a coffee, and you were the first Chinese student we actually welcomed in our lab. So we didn't know what to expect. You maybe also didn't know what to expect from us. And then you told us where you're from in China. I'm very ignorant. I have never been to China. I don't know much about it. I'm now very curious. But you mentioned that you are from a small town called Wuhan, which I've never heard of. That was 2019. It didn't take long before I knew what Wuhan is. And to my also ignorance, Wuhan has, I don't think, is more than 1 million inhabitants, so it's not a small city, right? So I should have known it, but I didn't, so I apologize for that. And then during our first meeting, we invited you for lunch at Banditos, and you had, I don't know what you had, maybe a Dutch broodje of a soup, and we, wondered, whether you like it here, the atmosphere, and you were very polite, always friendly, and when you started having your first taste of, let's say, Maastricht or European food, I remember you saying, "I think I'm going to lose a lot of weight here." But he said it with so much conviction and politeness that we didn't know what to think about it at the time. But it made you indeed, also reflected in your acknowledgement, you actually did cook quite a lot. And I remember that at one point you also invited the entire group to I think it was a Chinese New Year's Eve, and you cooked for all of us. And I was very much looking forward to this invitation. But a few days, and also shows a little bit your character, a few days before the day that we are supposed to come to your place for dinner or for food, we received a PowerPoint presentation of, I don't know, 20 slides. And I thought, what does a PowerPoint presentation have to do with a dinner invite? But on each slide, there was a picture of a delicious meal with a number next to it. And we could just select the numbers that we think are looking tasty, and we could select this. So it is really fulfilling all the stereotypes I have from a Chinese restaurant. And I apologize again that I put down so many numbers. And you had to cook all these dishes, which you actually did. So it was a very pleasant experience for us. What I'm trying to say is that it was wonderful to have you in our group. You had indeed a difficult start with the coronavirus and the lockdown and everything, but you persisted, you didn't give up, and I'm sure it must have been very difficult for you, the cultural shock, the science, all the circumstances against you, but you fought your way through this. And I have to say, it is amazing how much you developed in those 4 years here with us in Maastricht, how you grew as a person. So you not only lost weight because of the terrible food, but you also grew as a person. And I think this growing as a person is very much thanks to your supervisor, which is Felix, who is probably also very proud of your performance. And this would be the moment where I thank you again and give the word to Felix for the laudatio.
Yes, thank you very much. You obviously cut the number of talking points in half. Of course, you always do. No, thank you very much. So, let me see, I have some notes here. Ting, Dr. Wang. Congratulations, obviously, to you and your family. This has been a very nice session. I'm very proud of you. And it's been indeed a very long journey, right? A journey that started long before you came to Maastricht. And I think this is a real milestone and accomplishment. And I hope we remember all of this, obviously, as being a very fruitful and good journey and a happy day. There are a couple of themes, indeed, that stand out over the last 4 years. Food is one of them. I also vividly remember this moment where you realize that Dutch food is very different from what you're used to, and that a cheese sandwich is not the most pleasurable thing, at least on your own menu. I'd like to double down on this, just already right in the beginning. I think that my favorite memory of this entire journey was when we were at a conference in Hasselt, and our nice Belgian host thought that they can spoil us with an entire plate full of cheese. And wine, obviously, yes, right? Your two favorite things in life. No, and they were nice enough to give a few crackers on the side, but also fruit and some lovely grapes. And I should have known better, but I thought cheese and grapes, this is really a match made in heaven. And I tried to convince you to give it a try. And you did, and I'm still sorry, and I have to apologize here. The face you made of disbelief and, let me be honest, disgust, I will never forget. And it drives home this point that this has been not only a scientific journey, but also a real cultural challenge. You came here from a very different place, and I think the magic of this project and our collaboration is that we somehow, I think, managed to meet somewhere in the middle. It's difficult to define, but I'm not so sure who learned more from our collaboration, you or me. But I'm incredibly grateful what you've done, let's say, here in our group, what you taught me about science, but also life, and how pleasant you have been to work with in this entire section. And I want to highlight one particular role you had. You paved the way for this entire group of lovely CSC students we currently have in our section. Without you, this probably wouldn't have happened. You played an instrumental role in making them feel welcome, to help them with their applications, and to build this little sub-community, but I won't call it a bubble, because I think an accomplishment of you and all of us together has been that we've grown to like each other, work together, appreciate each other, and form one coherent, united group. And I think that's a lovely example of what science can do. Talking about the science, I think our hand was forced a bit by circumstances. We mentioned the pandemic, the labs were closed, all those kind of things. But this wasn't by choice, and we couldn't exactly do what we set out to do, but we made the best of a difficult situation, and the end product is really something I am and you also should be proud of. The varied methods we've used, from meta-analytic approaches to DDM model analyses and EEG, online and lab-based studies, I think is a fantastic collection of our joint efforts. And when I look at your thesis, I think we've done well, and you've done well in particular, and I just helped a little along the way. Food has been the theme. I know now what a dragon boat festival is. I know how to celebrate New Year's. So all of those are very good memories to me. But the most important thing is the human factor on all of this. I want you to know that you're one of us. You carry a little bit of Maastricht in you now. You will continue a postdoc in China. And I hope that you bring this piece of Maastricht that you have now to the rest of the world and let it inspire the rest of your academic journey. So you have your academic home here. I'm just very happy how all of this went. I learned from you, 666. You did amazing. I will tell everyone about this. I wish you the best of luck indeed with your next steps, and know that we are here and you know where to find us. So thank you very much, Ting.
Okay, so dear Dr. Wang, also on behalf of Maastricht University, I congratulate you with the degree that you have acquired. Now, before we, there will be a reception. It will be in the room over there. It's called the Refter, but we will also take a few pictures. And also the opponents who are not here but who are online, maybe they want to say something to you, because they cannot do that during the reception. So let's start with Dr. Taylor. Maybe you want to say something to the candidate.
Thank you, Pro-Rector, for the opportunity. I'd just like to congratulate you, Dr. Wang. That was a fantastic talk and a great discussion. And I think your supervisors and family are right to be proud of you. So congratulations.
Okay, thank you, Dr. Taylor. And now we go to Professor Kotz.
Well, thank you, Dr. Wang, for the very professional presentation today, both in terms of your slide presentation and the discussion. I really enjoyed it very much, and I wish you all the best for the future. I can follow some of your points about the Netherlands and the rain in particular. So it was very, very entertaining to hear your thoughts. All the very best.
Okay, thank you, Professor Kotz. And that is the end of the ceremony. So we will take a few pictures right now, but you can already go to the Refter where the reception will be held. Yeah, and that's it. Thank you.
All right, please. 我们可以照相了。是要跟那些教授们照相。对对对。